I'm going to introduce Nancy Eckert. She is talking about swarm intelligence and human systems. So Nancy has been a hacker hailing from right here in this local area, Seattle, Washington. She's been playing games on the internet since the early 90s and was a purveyor of text-based MUDs. She is now a champion strategist and community organizer in the world of competitive augmented reality gaming. Nancy leads hundreds of players in Capture the Flag events around the world. Can we all give a warm, welcoming round of applause to Nancy?
Hello, Portland. Hello. Thank you so much for coming here. All right, I'm Nancy Eckert. Some of you may actually know me by my gaming handle, Pongolin, or just Pongo. Like some of you, I imagine, I found my way here today because of games. So my first exposure to the internet was through games. On a spring morning in 1993 or so, some friends of mine invited me to a lab in a basement at the local college where some of our older siblings were taking classes to play a text-based adventure game called a MUD. And in a few short hours, I learned that I could use something called Telnet to talk to people in Sweden. Now, I didn't know what Telnet was, and 1993 was a year before you could really Google things to find answers to things like that. But I wasn't gonna let that stop me. So within a few weeks, I taught the modem at my school library to connect to the university using this thing called Telnet, so I could play games at school and talk to my friends across the world. The following year, I scheduled a free class period in the library as a monitor, and I became the best student library worker my school had ever seen, and I was never caught. I even helped fix the computers. So games are incredible motivators, and we'll talk about that a little bit more later on. What I love about gaming, though, is that gaming, it offers some really unique opportunities to simulate systems that may or may not actually exist in the real world in order to solve problems that do. You can make a game simulate just about anything. Furthermore, games remove obstacles for communication. They give us opportunities to take calculated risks in environments that are generally lower stakes than the real world. Humans have used games for thousands of years to exchange information and facilitate cooperation, to teach important survival skills. You can think of some of the games that we might have played as children: house, hide and seek, war. Play is critical in the animal kingdom for teaching important survival skills, and perhaps one of the most important survival skills in human systems is how to function as part of a group. So there's a specific game that I'd like to talk about today, very briefly. It's called Ingress. This is an augmented reality video game. Anybody play Ingress? Yeah. Enlightened? Resistance? Would you tell me if I asked? I'm enlightened. Anyway, so this is an augmented reality game, the predecessor to Pokemon Go and Harry Potter. Unlike these two games, Ingress has always been player versus player. It's a team-based player versus player game. There are two opposing player teams. It's fixed sum, so two teams are competing against each other directly for the same resources in a very capture the flag style format. The game is also played in physical space, in real time. There is no off button, and generally speaking, the game is played by going to a specific location and performing some action on your phone. Hopefully you have internet access. So this team-based competition in physical space brings two very important and powerful primal forces into play: tribalism and territoriality. The competitive game involves going to places that are in some way challenging to get to, which can sometimes require special equipment, skills, or intelligence. Big points are scored in the game by means of secret operations involving precise cooperation between dozens to even hundreds of people across the world. International operations exist. Operations exist where people do not share the same common language. The emergent social game is ruled pretty much by spreadsheets and intrigue. And in many of these operations, if one person fails to do their job correctly, the entire operation is a wash. Generally, it's hundreds of hours of planning just down the drain. Now, I like to study and occasionally interact with systems, particularly intelligent ones. So I played this game pretty competitively for about 5 years. Became a community organizer with an area of operations roughly covering the Cascadia watershed. I've won several tournaments across the world, and I also helped found a guild that eventually became a religious order, ordained its own priesthood, so I guess you could say I'm a cult leader. So I did learn a lot in this game about how groups interact in physical and digital spaces. I learned a lot about social engineering, that is, persuading people to act in certain ways, usually to go to a place to do a thing, so you can beat the other team for the win. I learned a lot about why people cooperate and why they often don't. So some basic challenges to cooperation are illustrated by two classic problems in game theory, which I'll briefly describe here. The first one is called the Stag Hunt. So the French philosopher Jean-Jacques Rousseau described the stag hunt with a kind of story. Two hunters can either cooperate to hunt a stag, which is harder than a hare, or they can individually hunt a hare, which only feeds the person that caught it. Cooperation is a choice that requires trust that the other party will not defect, but this trust has a cost associated with it. To give you maybe a real-life example, you have a security consultant and a client. This is a cooperation built on trust. You must cooperate to achieve your mutual goals of better security. However, cooperation comes with a cost. The security consultant doesn't want their hard work to be wasted finding solutions that will not be implemented. The client doesn't want their money to be wasted on solutions that cannot be implemented. So this is an example of a stag hunt. Perhaps a better known example is the prisoner's dilemma. This also describes the problem, albeit in a slightly different way. So suppose that the two players here are represented by the colors green and blue, similar to the game, and that each player can either choose to cooperate or defect. If both players cooperate, they both receive a payoff for cooperating. If they both defect, they both receive a punishment. If blue defects while green cooperates, then blue receives a larger payoff, while green receives sort of a sucker's payoff, a punishment. Similarly, if blue cooperates while green defects, blue receives a punishment while green receives the payoff. So both of these games illustrate a basic problem of cooperation. Misplaced trust has a significant penalty for the nice party that doesn't defect first. So this model of the prisoner's dilemma assumes that the parties can't actually communicate with one another. However, there's a very interesting variant on the prisoner's dilemma called the iterated prisoner's dilemma, where you can evolve a strategy based on what's happened in the past. So there's a Professor Robert Axelrod created a series of contests in order to find a winning strategy to this iterated prisoner's dilemma. He invited experts from many different industries to compete. And the strategies submitted ranged from very nice, that is, always cooperate no matter what happens, to always defect, very mean strategies. And Axelrod discovered some pretty interesting things about humans playing this game. The first one was that cooperation required, in almost every case, for there to be a chance of a repeat interaction later on. That is to say, on the last round of the game, everybody knew that it was the last round, everybody defected to maximize their gains. Axelrod's contest also found out that the long-term gains over time were achieved by strategies that used a very simple tactic. So simple, it took about 4 lines of code to express. Basically, it was this: lead with cooperation, and then do whatever your opponent did last. It's called tit for tat. And it won everything. Axelrod ran another contest, and it won again. Even against, he let everybody know that tit for tat was going to be in this second contest, so people were intentionally trying to beat it, and were not able to do so. So he analyzed the short and the long-term games against nice strategies and mean strategies, and specific vulnerabilities against them. And eventually he arrived at a slightly revised version of this strategy. It was called tit for two tats. basically lead with cooperation, forgive the first defection, and then do whatever your opponent did last. So, world peace, right? We figured out human behavior? No. Humans are messy. Human systems have all sorts of biases and competing goals and new problems that are introduced because of these competing goals, and they always become more pronounced at scale. One criticism of game theory to predict human behaviors is that the models quickly become too complex to even model and understand. Still, we might have touched on something here with this idea of leading with cooperation. So the problem of cooperation with MMOs and augmented reality games can also be mapped out to a kind of Stag Hunt or prisoner's dilemma, and many times the incentive is built right into the game rules. Better rewards, usually loot, require more cooperation, and in many cases, the more cooperation you get, the better reward you get. And a lot of times, again, if one person defects, everybody goes home empty-handed or pays a penalty of some kind. So maybe the most interesting takeaway from Axelrod's experiment was that he found out that even small, isolated groups using the tit-for-tat strategy could eventually outscore long-term against large populations of greedy strategies or mean strategies. The secret to this was something called clustering, which is the tendency of people using nice strategies to interact favorably with each other. The key was that these small pockets of cooperation connecting to each other was what enabled them to basically pay out these long-term gains. So this is a really important thing to keep in mind when you're seeking to coordinate large groups of people. The relationships between the people in the group, particularly their likelihood of cooperation or defection among each other, are fully as important as the people themselves. And so the organization of free agents in a system is a basic problem of cooperation. And this is one more example of how games can simulate real-world systems with slightly lower stakes. And this is where guilds come from. Guilds are systems for organizations in games in order to facilitate cooperation, and one would hope without resorting to force or bribery. When we're building an organization, like a gaming guild, this is often the first system that we try to build. It's a pyramid. This is a very intuitive structure. You have your founders at the top, guild leaders, calling the shots. Maybe they have a cabal of trusted advisors near the top that are come up with many strategic solutions. And then at the bottom of the pyramid, you have your so-called rank and file. In gaming, a lot of times they're newer players, maybe they're casual players. But if the people at the top are understood to be the strategists doing the planning, the people on the bottom are the ones tasked with executing those plans, hopefully in service to some goal common to the entire team. Information flows from the top down, and if you're at the bottom, chances are you have an individual goal of working your way up to the top. So this approach has some strengths. Again, chain of command is very well understood. It answers that question of who's in charge very decisively, which can be invaluable in many ad hoc situations, particularly emergency situations. However, it also lacks flexibility. It lacks the ability to adapt to changing needs, and systems analysts refer to this as a brittle system. It's fairly vulnerable to attack in a few key places, namely near the top of the pyramid, where the information comes from, where the decision-making comes from. If you compromise the guild leader or the CEO, you own the entire system. But what if we could do something like this? At first glance, this may just look like an unintelligent mob, but in actuality, there's some crazy teamwork going on here. Each node in this network, this group of starlings flocking, is interdependent to maximize its effectiveness. Now, this isn't a new concept. It's used widely in programming, and this is not accidental. Just as artificial neural networks are patterned on our understanding of how the brain works, artificial swarm intelligence in computing is patterned on observed behaviors in the animal world. Fish, schooling for defense, reducing threats to the individual through collective action. Army ants solve complex problems through cooperation, adaptive specialization, and communication. They use pheromone scent trails to communicate with each other, and they make rapid decisions through a kind of consensus building. It's very fascinating. So what exactly are they doing? To use a programmer's analogy, they're following a set of very simple instructions, generally things like don't run into other animals. And they're processing information from their nearest neighbors. How close is my nearest neighbor? What direction are they going? That sort of thing. So when I first started speaking on this subject, I used swarm intelligence to refer to a set of competitive strategies in Ingress that my teammates and I developed in augmented reality gaming through a highly iterative process, basically to meet the challenges of tournament play. Rules would change frequently, as would our playing field and the composition of our teams. So over time, our strategies had to adapt and become more flexible. Swarm intelligence started as a metaphor for how to organize movements of large groups, hundreds, sometimes over 1,000, basically larger than Dunbar's number, in public spaces. These are actually 2 slides from a tournament in downtown Portland in 2017. So using this metaphor for pre-programmed instructions and nearest neighbor communications, we came up with a strategic model that was consistently successful in tournament play. We found the traditional command and control structure, while useful, was terrible at adaptation. It was also very slow. When you have information that's being relayed through multiple channels all the way from the top down to the bottom, you lose precious seconds, and that could cost you the game. It also leaned heavily on single points of failure, prone to information bottlenecks and siloing. It scaled poorly. Guilds ran by a single figurehead in that sort of pyramid model tended to max out at about 150, there's Dunbar's number again, players or so. We started looking at other games. We ran across EVE Online's appropriately named Goon Swarm, infamous for rolling over their competition with armies of new players. But things really started to get interesting when we discovered that these tactics in use outside the game. And one of the first examples we found was the US military. So General Stanley McChrystal, perhaps best known for his command of the Joint Special Operations Command, fighting Al-Qaeda in the mid-aughts, describes their decentralized organization, basically a swarm, as something the US military forces under his command actually had to emulate. This is something that Al-Qaeda was doing that they had to emulate in order to fight them effectively. And what they found was that timely solutions for unknown problems tended to emerge from the bottom up rather than from the top down. So he refers to this as the team of teams approach. One very different implementation of swarm intelligence was the Swedish Pirate Party. Founded in 2006, the organization elected members to parliament and expanded to 33 countries through an approach that is literally described by its founder as a swarm. He wrote a very excellent book on this. I do actually have a reading list at the end of this slide presentation if you're interested. Its success, he relates its success to a conscious effort to empower the end nodes in his organization. Many of them were young people. So to reiterate the qualities of a swarm and why we might want to organize something in this manner. So this offers solutions for many of the challenges we just talked about in the command and control pyramid approach. When done well, swarming is an incredibly fast and efficient way of coordinating large groups, hundreds or more. It's flexible. One of the most desirable qualities of the swarm intelligence framework is adaptability. These strategies can be applied to several different scenarios, and they can integrate really well with more traditional hierarchies. It's also quite resilient. When you attack one part of the system, in contrast to our command and control structure we talked about earlier, attacking any single part of the system doesn't really accomplish a whole lot. Since the swarm doesn't need information from a leader of the entire swarm, removing any one node here merely establishes a new nearest neighbor. So it has this quality of resilience that resembles a self-healing organism. And it's efficient. It leverages the skill set of the entire group as opposed to just the people at the top. Again, this is in particular is what the Swedish Pirate Party attributes its massive success to. Now, these are all really excellent qualities and advantages, but there's also a hidden possibility here, and that's collective intelligence. That is problem solving at scale. This is really the brass ring that we're shooting for here. So when individuals acting autonomously, they have a strong purpose, mastery in what they're doing, and communication with their nearest neighbors. Collective intelligent behaviors will start to emerge. Swarm intelligence strategies prioritize empowerment, again, of the entire network, focusing on what everyone can do. Swarms benefit from and leverage diverse perspective and skill sets, and because they're adaptable, because they're resilient, because they're efficient, they can solve big problems, problems that are too complex for any one individual to understand, sometimes without even consciously realizing that they're doing it. Any D&D fans out here? Who plays a bard? Tell me what you think about charisma-based skills. They break the game, don't they? Anybody ever DM'd with a bard in the party? Yeah, it's fun. Social engineering is concerned with exploiting psychological vulnerabilities to influence people. And trust and information flow impact relationships between agents in a system. So it makes these intuitive routes to soft power. So we talked about leading with cooperation for max gains over time. So how do we do that? When we're building trust in a large-scale social system, whether it's gaming or not, newbies are the most vulnerable and important agents in the system. And why is that? Bluntly, it's because they're the least informed. In a tribal situation, whoever gets to the newbies first will often have great influence over them later. In MMOs and ARGs, helping the newbies is a great way to build a guild, and it is also a path to leadership. A lot of people will establish trust with new players via power leveling. They use mentorship and sponsorship to build trust and to convey information about your values, and ultimately to define new win conditions. This is a double-edged sword, of course. Like any viral infection, information offensives work by targeting the most vulnerable members of a population, in this case, the least informed. In some cases, it can be recognized as an actual bid for power. We've seen in games, there have been incidents of, say, bad actors reaching out to new players in public channels, establishing themselves as gatekeepers, promoting competing viewpoints, and in a couple very unfortunate cases, isolating people from the community. So let's step back to motivation for a second and social engineering. So any hacker knows that the tools to disrupt the system are the same as the ones used to empower the system. So how can we use these tools for good? Anybody recognize this badge? Yes. So when one of the guys at the local hackerspace heard that I was going to DEF CON last year, he gave me a small plastic badge with a bunch of dice printed on one side. He told me the badge contained a secret message about an exclusive party, and he challenged me to break the code. Within about 48 hours, I knew more about cryptography than an online course from MIT had taught me in a month. I also had learned one or two things about cross-site scripting, but that's a story for another time. Gamification is, in fact, the most reliable motivator on the planet. Games have been shown in many cases to be more reliable than just about any other motivator to get people to act for or against their own self-interests. Now, the reason for this is in large part due to two very important chemicals in our brain. One of them is oxytocin, which is fundamental to trust and bonding. It is present in all social games and really all social systems. The other is dopamine, which controls our reward centers and defines what we think of as worthwhile experiences. Add them together and you have a powerful cocktail for social engineering at scale. So in 2008, a group of researchers at the University of Washington created an online puzzle game called Fold It, which gamified, of all things, protein folding. Fold It leveraged the pattern recognition abilities of thousands of human players and in some cases outmatch the problem-solving abilities of computer algorithms. The researchers refer to Foldit as a serious game, and they would go on to produce several more. So these serious games have crowdsourced many, many advancements in science and medicine, basically by breaking these complex problems down into teachable bits, presenting those bits in a gamified context, and then just catalyzing large-scale cooperation and communication among its players. Meanwhile, at a conference like this one, we have many games to increase engagement, but also to teach the skills relevant to security. So I hope all of us here at BSides are involved in a game like this, but what I'd like to do today is break down the structure a bit, because I'd like you eventually to all create your own. The first thing you need to do is establish your win condition. This is the reason your game exists, or organization. It's sometimes called a vision or a purpose. It can be something like collect flags, fold proteins, work through this mountain of data to find the patterns. Capture the flag, security capture the flag is a very obvious example. The second thing you need to do is break it down to those teachable bits, those first principles. As far as possible, you need to break these skills down to digestible bits that can be mastered, and this is important, autonomously. It is not enough for you to give people the information they need and help them along. You need to empower them to not only master these skills, but you need them to be able to teach these skills to other people without your oversight. So ultimately, agents in the swarm need to be able to train others to do the same. This unconscious competence, mastery, is one of the necessary conditions to unlock this collective intelligence we were talking about earlier. So the more we can do autonomously, the more mental bandwidth we all have for focusing on higher level tasks. So one of my favorite examples for a game that does this is Locksport. One thing that I love about it is it's got a great learning curve. Somebody can pick their first lock in an hour of practice, and they will come back with a completely transformed perspective on physical security. This makes it a wonderful game for people new to the security industry. Plus, it's cool. It's fun. I like picking locks. The third thing you need to do is establish and facilitate communications with everybody's nearest neighbors within your swarm. Again, it is not enough to make sure you give them all of the information they need. You, as the game designer, need to get people talking to one another. One other great example would be many of the badge games that are created for InfoSec conferences. I particularly enjoyed the DEF CON badge games from DEF CON 26, where that enabled chance encounters. I think they all do this, but enabled chance encounters between strangers for a win condition. It's got people talking to one another, but also talking to one another about the things that they cared about the skills that they had mastered. So here's where we start to see how we can use games as a way not just to teach skills mastery, but to perform social engineering at scale. From an organization as small as a gaming guild to grassroots movements with thousands of members, there's a real power here, and it's a power that we all possess. You all possess. You all have this power. It can be used to empower and disrupt. And it is my hope that you all now can recognize when it's being used and in whose interests. Anyway, you all now have the guidelines. Make good choices.